Hey, everybody, welcome back. My name is Sean, and this is Science Hunters, where we at VML Health talk about recent science that's got us excited that we think can impact both medicine and general health going forward. Topic today I'm going to be talking about is autoimmune disease, and I'm going to start with a really shocking statistic. So there's about 50 million people worldwide who have an autoimmune disease, and 4 out of 5 of them are women, 80%. And so the study I'm going to talk about today began to explore what might be the biologic underpinning for how women are so much more at risk of getting autoimmune disease. Study was done by some folks at Stanford University and published in a recent issue of the journal Cell. And I'm going to start with this article and talk about chromosomes. So break out your AP Bio textbooks from high school. We have 23 different pairs of chromosomes. And in 22 of those cases, the pairs are equal. And genes will be expressed on your chromosome from your mom or your dad, and they will combine and they will determine what you look like. Do you have brown hair or blonde hair? Do you have blue eyes or green eyes? Are you tall? Are you short? That is all a combination of genes being expressed by different members of that pair of chromosomes, okay? However, there's one pair of chromosomes that is an exception, and that is your sex chromosomes. And why is it an exception? Because there is an X chromosome and there is a Y chromosome, and they are not equal. Okay? The X chromosome is the size of a full chromosome. It's got a lot of information on it. The Y chromosome is this little itty bitty chromosome that doesn't really do a whole lot. And all it really does is code for certain things that make people male. So how you make sperm, things like that. Okay, there's very little other information on that Y chromosome. So how does biology deal with the fact that you have 2 unequals that are not expressing the same level of genes? In certain cases, you might not have enough information. You might have too much information. How is biology dealing with that? Well, biology deals with that by something we call chromosome silencing, or X chromosome inactivation. What are you talking about, Sean? Basically, in females who have 2 X chromosomes, 2 copies of the X chromosome, we will turn one of them off. Okay? And this is cross species. Evolution has figured out a way to turn off the second copy of the X chromosome in females to make sure that both males and females are making the same amount of genetic information. Okay? And the way we silence the X chromosome is what is causing autoimmune disease in females. There is a molecule called XIST, capital X, small I, small s, small t. And XIST, all it does is bind to the second copy of the X chromosome and turn it off. Silences it. Prevents any of the information on that second chromosome from being made. Okay? And in most females, it works fine. But there's something about XIST that if it is defective, it can lead to autoimmune disease. And how do we know this? Well, this study took XIST and expressed it in a bunch of male mice. And they turned it on and off. They manipulated XIST in a number of ways. And they found when they turned it on in this kind of like not right way, where it's defective, those male mice specifically got autoimmune disease, just like female mice get of the same strain of mice. And the male mice who had XIST in it but turned on or was working properly, it didn't happen. So there's something really unique about the XIST molecule and the way XIST is structured. I'm not going to get into now, but it is a really cool molecule. When it's defective, it is underlying and causing autoimmune disease in mice. And this backs up what we know in humans, because XIST binds to a bunch of other proteins, and a lot of those other proteins are some of the stuff that people react to with autoimmune disease. They are known antigens in autoimmune diseases. So there is a link here with what we think is going on in humans as well. Now, what does this mean for treatment? We're a long way away, but it's gotten scientists now, they have a pathway and they have a place to focus their studies on and figure out how that defective exist molecule can ultimately stimulate the immune system and cause autoimmune disease. And as they study it, they will figure out ways to target that pathway and to interrupt that pathway and to help prevent autoimmune disease. So this is a very exciting study. I hope you are up on your chromosomes and remember all of that stuff. But really, as shocking as the statistic itself is, I think this sort of is a great example of basic biology being able to steer us clinically towards a place where we're going to be able to come up with great therapies that will deal with a huge problem, a bunch of different autoimmune diseases. So appreciate all your time. I'll be talking to you again really soon. And until then, science rules.